Hello and welcome to this IDS Vision Channel session today. My name is Patrick Schick and I'm Product Marketing Manager here at IDS. Before we start with this session, some housekeeping topics. If you have questions during the session, please use the Q&A section here in Zoom, or if you watch the video later on our IDS Vision Channel, please use the comment section on the IDS Vision Channel. And now let's jump into our topic, the market launch of Ensenso C, the next step for 3D cameras. To give you a short outlook what we talked today, we're talking a bit about the technical facts. We order the Ensenso C in the area of all the other Ensenso cameras. We talk about possible applications or still realized application with the Ensenso C. And last but not least, we will have a look on live image from the camera here directly in the session. And then for sure, it's time for your questions. So let's jump into the facts. With the Ensenso C camera, let's say we have a classical active stereo vision camera. For those who know the Ensenso C, the Ensenso product lineup, I would say you can easily say that it looks like a combination of Ensenso N and X series. And at least, let's say, I have to say, you're right, but step by step in this topic. First of all, we have a classical active stereo vision camera. We have here on the right and the left side a 5-megapixel mono camera with a well-defined distance, the so-called baseline. And the Ensenso C comes with a 200-watt pattern projector. This means you can expect the same high quality and precise 3D results as from all other Ensenso active stereo vision cameras. As we're talking here about a 5-megapixel sensor is included, we can safely talk about a set precision of 0.1 millimeter at a 1 meter distance. The 200 watts projector adds a better contrast also in critical environments like nasty surfaces or too much ambient light. The camera comes in a compact housing with only 2 connectors here. We have the M12 connector, the Ethernet connector to connect the camera to the PC, and an I/O and power connector to power up the camera. If you use PoE, you have only to connect 1 cable here at the camera. So we have a small, compact housing. Just this. So next topic, as told before, back to our initial thoughts, the N series fits perfectly, as you can see here, into the series of Ensenso cameras. So it fits between the N and the X series because the camera combines the highlights of those series perfectly. A 3D camera in a fully integrated housing with various baselines and a high power projector. But additionally to this, the Ensenso C comes also equipped with an RGB camera, as you can see it here, which extends the usage of the camera to all cases where not only a 3D point cloud, but also an RGB image is necessary to do the job, or even the combination of both. Let's have a look to some applications which heavily profit from this feature later. Besides the RGB camera, the Ensenso C is also equipped with an internal light to be able to take images also under not optimal lighting circumstances. And last but not least, the Ensenso C comes in two baselines to cover working distances from 0.5 meter up to 5 meters. We have here the Ensenso S with a baseline of 240 millimeters. And additionally, we have also an Ensenso M series, this one here, with a baseline of 455 millimeters. And to give you a glimpse of comparison, to summarize the first part of this section, if you compare the named features realized, I would say you can immediately see that the Z series comes as fully equipped 3D and 2D RGB camera in a slim housing. And if PoE is used, only one cable, the Ethernet cable, is necessary to work with the camera. I gave you here an example how Ensenso C or Ensenso X or also an Ensenso N setup would look like with the integration of an RGB camera, and how slim and fine it looks when you use the Ensenso C. So we had a first look on the facts of the camera. Now let's have a closer look of applications which are realized or can be realized with the Ensenso C camera. First of all, as you can see here, we have a classical bin picking application on the left side. As with any other Ensenso camera, you can solve a bin picking application, but with the additional feature that here you have the possibility to not only pick the items, you can also sort the items by color, in this case, based on the integrated RGB camera. So one value ahead, if you have an unsorted color box, you can just sort them also by color, pick and sort. On the other hand, we have the detect and recognize feature. You can directly check, for example, luggages, or inside of logistics, if it comes to parcels, you cannot only check the size and measurements of the object. Additionally, you can also document the outline, and even also, again, we have integrated RGB camera. You can also document the texture and everything else. So the RGB camera also brings back to the mind that with every Ensenso camera, you have access to a mono image. For example, as you can see in the image here, if you have in logistic parcels, you cannot only, again, have the size and the position of the parcel. Also with the mono camera, you can read barcodes or text on these parcels. And this is not a special feature of the Ensenso C camera. This is a feature of every Ensenso camera. Every Ensenso camera gives you the ability to use a mono image for further tasks. But here we have a 2D camera, a RGB 2D camera, included again. And so let's have a look on some applications where this is in use, this combination. The 3D and RGB combination comes majorly in place when it is necessary to use artificial intelligence in the machine vision process. For example, as you see on the commissioning on the left side, first to detect the type of item and decide based on this information how to grip the object. So on the left side, on the commissioning part, let's think about you would like to check which cornflakes you pick, and for example, also which gripper has to be used. Or on the right side, kind of truck unloading, when you pick totally unknown object, and also here based on the AI, you have to find the object, the boundaries, and can also decide about the quality and the type of the object. And again, what kind of gripper has to be used. Or additionally, when the texture gives the necessary input, what kind of object has to be gripped or handled or sawed, if this depends on the texture. Another benefit is that, as you can see on the right side on the truck unloading wall, for only a 3D camera, the lower image, the end of the truck would only be a wall. And it could not really distinguish between the parcels. With additionally 2D machine vision systems, you can also do a boundary check and really can find the lines between the parcels and separate them to grip them one by one. Another relevant topic is the data quality for applications with bigger volumes and higher working distances. In this kind of applications, the Ensenso C can point with its high resolution sensors, which leads, as told before, to a set quality of 0.1 millimeters per 1 meter distance. So even in a 5 millimeter distance, you can get a set quality around 0.5 millimeter. This quality enables you to do a precise picking or quality checks of objects, like here shown with the car bodies. So on the left side, we have, again, a depalletizing applications. As you can see with the Ensenso C, if you, for example, use the one with the bigger baselines, you can completely oversee a pallet and get the quality to pick those single boxes from the pallet. On the right side, when it comes to test and measuring, you can also combine the Ensenso cameras together and then measure and check the quality of those, for example, of those car bodies. Again, a feature which comes with every Ensenso camera, you can combine the Ensenso cameras into one system, let's say. So you can calibrate them together, and then you get one single 3D image out of this example for Ensenso cameras. So with one shot, you can do a complete 360 degrees checking, for example, again, of these car bodies. And I would like to show you one kind of applications which a customer solved still with the Ensenso C. We have here an application where automotive parts get picked and separated, loaded in a box on wheels with holders for the parts. The tolerance of these holders requires a precise loading in the millimeter dimensions. So in this application, the Ensenso C with the M baseline with the 455 millimeters is used And therefore, they get the precise measurement that, as you can see on the left side here on the images, you can really precisely place the picked items in this container where they get then transported to the next station. As you can see, there is not really much space, but with the Ensenso C, you get the precise data to place them there. Another feature in this case, which is used, it's not only used as a pick application, also due to the 200 watt projectors, the bigger distance you can go, and the high precision, also the quality of these boxes where these items get loaded into is checked by the Ensenso C. And if they do not meet the required tolerances, nothing will be loaded into this box. So the Ensenso C is used for two different applications. First of all, classical bin picking application with a high precise requirement on placement of the object. And on the other hand, as a measurement and quality check system to ensure that the boxes where these items are placed are in the right quality and in the best shape for it. If you want to know more about these applications, I would like to invite you to our online event of the 21st of November. There, this customer will present their solution in much more detail and much more deeper insights as I've done this now. So check out our website and check out our IDS InsightImaging event. Not only the Ensenso C will be presented there, we also show news and techniques about upcoming UI cameras, what is feasible with AI and IDS NXT. So check out our website. There you get more information and register for the 21st of November. Okay, we had now talked about the technical facts. We talked about applications. And I promised you that we also will have a look on the live images of the camera. Therefore, I will switch to the view of the Ensenso C. So here we are in NxView. And we have here the visualization out of the Ensenso. I place something right here. I placed my iPhone now on this box. As you can see here, we have a 3D representation with the texture directly matched to the 3D data. And additionally, I've just also activated partfinder. Partfinder, which is included in NxView, enables to find, based on CAD data, known objects. I placed the three housings here. And as you can see, with high precision, we find the objects. You get directly the pose out of it. So not only X, Y, Z, also the rotation, that you get the necessary input for next step, for example, for your robot to be able to pick this. As told before, with this application, we have here red, white, and green placed. You would be able to directly pick and sort them by color. And here you can see a bit more of my setup. You can directly also get the information of the 2D camera and use them for further applications. So, also a short glimpse to our Ensenso C. So last but not least, let's shortly summarize the session before we come to your questions. We have a 3D camera in a fully compact housing with 5 megapixel resolution, which leads to a set accuracy of 0.1 millimeters per meter. We have different baselines of this camera available, and an included RGB camera to extend the features of the 3D image, for example, to get textures, to do AI, or to do more machine vision with these images. Thanks for joining. Thanks for being here. As told, check out our website, check out about our InsightImaging event and register for it. A half a day full of information about the newest topics at IDS, also about the Ensenso and Ensenso C cameras, use cases directly presented from partners and customers. Check out our website. Thanks for watching. I wish you a nice afternoon.